Welcome to a slow, beginner-friendly lesson on tuples in Python, made for absolute beginners. The lesson begins. Welcome back. You met tuples briefly, an ordered collection in parentheses, like 3, 4. Today we answer the real question: when do you choose a tuple over a list? Both hold ordered items. Both support indexing and len. The difference is practical and philosophical. A tuple is fixed and cannot change. That sounds limiting, but it is a feature. Let us see why. A small type with a big purpose. Quick recap. A tuple looks like a list but uses parentheses instead of square brackets. Point equals 3, 4 creates a tuple of 2 items. You can read items by position, just like a list. But you cannot change them. Once a tuple is born, its contents are locked. This is called immutability. A list grows, shrinks, and changes. A tuple stays exactly as it was created, forever. Locked from the start. Some data should never change. A coordinate, a color, a birth date. These are fixed records. Once written, they stay. Tuples exist for exactly this kind of data. Some things stay fixed. Let us create a tuple. Point equals 3, 4 inside parentheses, a tuple of 2 numbers. Color equals 255, 128, 0, a tuple of 3 numbers for red, green, blue. The order matters, just like a list. Point square brackets 0 gives 3, the first item. Len of point gives 2. Read-only access works exactly like a list. Parentheses mean fixed. Now the key difference. Try to change an item. Point square brackets 0 equals 5. Python raises type error. Tuple object does not support item assignment. The tuple refuses. You cannot replace, add, or remove items after creation. Compare with a list, where you reassign any item freely. This lock is not a bug. It is the whole point of a tuple. Some data should never change. The lock is the feature. Tuples hide a superpower. You can unpack them in one line, swap variables with no temp, and return multiple values from a function. Small syntax, huge payoff. Small syntax, big payoff. Here is a pattern you will see every day in real Python. X, y equals point. Python unpacks the tuple automatically. X gets 3, y gets 4. No index needed, no temporary variables. You read it left to right and it just works. This is called tuple unpacking, and it makes code readable. Instead of x equals 0.0 and y equals 0.1, you write what you actually mean. Read what you mean. Unpacking works with any number of values. Name, age, city equals a tuple of 3 items. Each variable receives one item in order. You can also collect the rest with a star. First, star rest equals 1, 2, 3, 4. First gets 1, rest gets a list of 2, 3, 4. This star unpacking is powerful when you want the head and everything that follows. Star collects the rest. Here is tuple magic that feels like a trick. Swap 2 variables in one line with no temporary variable. A b equals b, a. The right side builds a tuple of the current values. The left side unpacks them back, but swapped. A becomes the old b becomes the old a. In many languages you need 3 lines and a temp variable. In Python, 1 readable line, and tuples do the work. 1 line, no temp. Choosing tuple over list is a signal. You tell the next reader, these values belong together, their count is fixed, do not try to change them. Code becomes clearer. Intent matters. Functions can return only one value, but that value can be a tuple. Define a function divide that returns result, error. When something fails, return none and an error message. When it succeeds, return the value and none. The caller receives both in a tuple. This is the most common pattern in real Python for operations that can succeed or fail. 1 return, 2 pieces of information. 1 return, 2 values. On the receiving side, you unpack immediately. Result, error equals divide of 10 and 2. If error is none, use result. Otherwise, handle the error. No indexing, no confusion. You read the line and know, 2 values come back, I name them result and error. This pattern is everywhere, in standard libraries, in web frameworks, in data tooling. Once you recognize it, you read Python faster. Unpack and name them. How do you choose between a tuple and a list? Ask one question. Will this collection change during the program? If yes, use a list. Lists let you append, remove, and update freely. If the data is fixed and should never change, use a tuple. A coordinate pair never grows. A color never gains a 4th channel. A date never changes. When the shape is permanent, the tuple is the honest and safe choice. One question decides it. Coordinates are a perfect tuple use case. Latitude, longitude equals 52.07, 4.28. Two numbers, always two, always in the same order. You never append a third coordinate to a position. You never remove one. The pair is permanent. Using a tuple communicates intent to anyone reading your code. This is a fixed pair, treated as one unit. Pairs that never grow. Colors are another natural tuple. Red equals 255, 128, 0. 3 channels, red, green, blue. Always 3, always in that order. You do not append a new color channel on Tuesday. The shape is permanent. When you see a tuple in code, you immediately know, these values belong together and their count is fixed. A list would suggest growth. A tuple says no. 3 channels, always 3. Here is a powerful reason to use tuples. Dictionary keys must be immutable. A string works, a number works, and a tuple works. You can build a dictionary that maps a coordinate pair to a city name. The key is a tuple of 2 floats. Lookup is instant. This is impossible with lists as keys, because a list could change and break the dictionary. Tuples are safe keys because they never change. Safe as keys. Watch what happens with a list as a key. Cities with a list of 2 floats as key. Python raises type error, unhashable type list. The dictionary refuses. Why? Because if Python allowed a list as a key, and you later changed that list, the dictionary would lose track of where the value was stored. Tuples avoid this problem entirely. Their contents are locked, so they hash reliably. Lists cannot be keys. Let us settle this with a comparison. Use a list when the data grows or changes, a shopping cart, a log of events, a queue of tasks. Use a tuple when the data is fixed in shape, a coordinate, a color, a date, a database row that should not change. Lists have methods like append and remove. Tuples have almost none, because they do not need them. Choose based on whether the data will change. Change or fixed. A practical detail. Tuples are slightly smaller and faster than lists of the same size. Import sys. Sys.get size of a list of 123 gives 88 bytes. The same call on a tuple gives 64. The difference is small per item, but in a program with millions of records, it adds up. More importantly, the immutability lets Python optimize tuples internally. Small wins, real benefits. Small wins add up. Let us name the real benefits of choosing a tuple. First, safety, you cannot accidentally change data that should be constant. Second, intent, a tuple tells the next reader these values belong together and will not grow. Third, hashability, tuples work as dictionary keys, lists do not. Fourth, a small speed and memory win. When data is fixed, the tuple is the honest, safe, and idiomatic choice. Honest, safe, and clear. Quick self-check. Can you explain in one sentence why a tuple is immutable? Can you unpack a tuple of 3 values into 3 variables? Can you swap 2 variables in one line? Can you explain why tuples work as dictionary keys but lists do not? If any of these feels shaky, rewatch the matching part. The goal is not to memorize syntax, it is to recognize when a tuple is the right tool. Say each out loud. Here is the lesson in one breath. Tuples are fixed ordered collections, like lists, but unchangeable after creation. They shine for data with a permanent shape, coordinates, colors, records, multiple return values. They unlock tuple unpacking, the swap trick, and dictionary keys. When the data will change, use a list. When the data will not change, use a tuple. That single question guides every choice. One question, one choice. What comes next? Having met tuples in depth, you now know all 4 collection types: list, dictionary, set, and tuple. Next we slow down on loops, how to walk through any collection one item at a time with for and while. After loops, conditions with if and else. Once you can loop and branch, you can write real programs. Collections, loops, and conditions together form the heart of Python. Loops are next. If you want a quick practice, open IPython and try these. Create a tuple of your latitude and longitude. Unpack it into 2 variables. Swap them in one line. Build a dictionary with a tuple as a key. Then try a list as a key and read the error. When these 4 steps feel natural, you understand tuples well enough to move on. Slow, deliberate practice beats rushing through the basics. Try each step. Thanks for learning when to use tuples. Next we begin loops, walking through collections one item at a time. See you in the next lesson.